Hello everyone, welcome to RN tutorials on engineering mechanics. In this video lecture, I am going to explain about how to find out the initial tension in a belt. It means the derivation part for getting the formula related to the initial tension in the belt. So almost you should understand it is initial tension means before starting the pulleys to rotate to transmit the power. So initially the belt can face a tension. So what is the tension? We need to analyze here. So first we go for a small explanation. So assume these are the two pulleys. One is a driver, another one is a driven or a follower. So or which we assemble or we mount or we fix the belt over the two pulleys to transmit the power from one shaft to another shaft. So when we are trying to mount this belt over the two pulleys, initially we'll be giving certain tightness to the belt over the two pulleys. That means with a certain grip, with increased grip in between the pulleys, we try to mount the belt over the pulleys. So when you are considering here the tightness of the belt, in the initial condition itself means this belt can face certain tension, which is the force tension force taking place in between the in the belt in tight side and the slack side. Okay, so that means due to the mounting of the belt with particular tightness, it can face particular tension in the belt in the stationary condition also. So assume here the initial tension before starting the power transmission also as T naught on both sides here. Okay, in tight side and the slack side both are equal by because it is in stationary condition. So when it starts rotation, okay, when the driver starts, the driven also rotates. So during this condition what happens, this downward belt side becomes tight because it will be dragging the belt in this direction and it will be leaving the belt in this direction, like that action takes place. So because of that, this one the downward one becomes tight and the upward one becomes slack. Okay, so when you are considering it is as a tight, the tension will be increased up to T1. Okay, initially it is maintaining T naught, then it again after starting the pulley to rotate, then the tension will be increased to T1. Okay, that is in tight side condition. Whereas in slack means it is becoming again which is light, not it is not tight. So in that condition the tension will be reduced. So from T naught to the reduction in the tension as T2. Okay, so the tension is reduced to T2 here. So like that the tension variation takes place during the power transmission between the two belts with the help of the belt here. Okay, so with this analysis we can find out the what is initial tension, which is the T naught here. So for that, what we have to do to find the initial tension in the belt, we should know that, okay, what are the conditions we need to find out. Okay, what are the terms we need to analyze for getting the T naught here, we have to know. So first thing is increase in the tension in the tight side. We need to find out how much the increment has been taking place. Here it is T naught to T1 is increased value. So what is the increment? Increment means the difference between these two becomes increment in the tension in the tight side. Similarly, we need to find what is the length increased in the tight side. So at the same time the tension is increasing means the enlargement of the, that means the enlargement of the belt takes place. So how much the enlargement may be resulting in the belt due to the increased tension, okay, which is just like elongating the belt. So that increased length also we need to find here. And similarly in this is these two increments are in tight side. So again in the slack side we can face the decrease. So what is the decrease in the tension in the slack side, we need to find. So it is decreased from T0 to T2, initial and final. So difference between these two will be giving the decrease. So similarly at the same time the belt will be compressed. So according to that, what is the decrease in the length of the belt in the slack side, we need to find out. Okay, so one by one we try to find, then we go for the formula for the T naught here. So first assume the initial tension in the belt as T naught, already we have represented over the diagram, and the tension in the tight side is T1. Okay, and the tension in the slack side is T2, and again the coefficient of increase or decrease in the belt length per unit force. So per unit force, how much the increase or decrease may be taking place according to the tension variation, that coefficient we are considering as a mu. Okay, with the help of this mu, that increased length and decreased length we'll be finding. Okay, so assume these terms. So according to that, we go for finding the increase in the tension in the tight side. So increase in the tension in the tight side already we have analyzed, which is the difference of two terms, T1 minus T0, larger value minus smaller value, that is the increment. Okay, similarly increase in the length of the belt in the tight side. So what is the increase in the length? Already we know how much the force, that is tension, increased. Okay, this T1 minus T0 gives us what is the increment. Okay, similarly when you multiply the coefficient, okay, coefficient is multiplication factor only. So when you multiply this coefficient of increase or decrease in belt per unit force, then it becomes increase in length. Okay, then try to write mu into T0, T1 minus T0 will give you increase in the length of the belt in the tight side. Similarly try to find, okay, before that assume it is equation as 1, and next try to write decrease in the tension in the slack side, which is again difference. Okay, so larger value minus smaller value, larger value is T0, smaller is T2, so automatically T0 to T2 will be the reduction, that is the decrease in the tension. And similarly what is the decrease in the length we need to find with the help of the mu. So again it can become mu into T0 minus T2. Okay, this is increment per unit force. So force will be getting cancelled, automatically increment becomes, so that is only decrease and here increase. So and again assume this equation as 2. Okay, so we go for next step. So what is the condition here? Here we need to assume the length of the belt is constant. So when you consider the length of the belt is constant, even there is an elongation and the compression is taking place. So what it means here, what is the increasing is taking place, that can be equal to the decrease also. Okay, overall the length is constant, so even the variation is taking place, means whatever the increment is taking place, that will be equal to the decrement also. So try to write increase in the length of the belt in tight side is equal to decrease in the length of the belt in slack side. So try to make these two equations equal 1 and 2, and write mu into T1 minus T0 is equal to mu into T0 minus T2. So cancel the similar terms mu and write down the remaining steps. T1 minus T0 is equal to T0 minus T2. So when you take the T0 one side and T1 and T2 one side, automatically it becomes T1 plus T2, because this minus T2 when goes to the left side it becomes positive. Similarly when this minus T0 goes to the right side it becomes positive, so T0 plus T0, so automatically it becomes T1 plus T2 is equal to 2T0. So T0 is equal to, we can write it as T1 plus T2 by 2. Okay, this is the initial tension equation in terms of the final tensions are taking place in the belts during the power transmission. Okay, this is the derivation equation derived by the proper analysis. Okay, and here not only the tension in the tight side and slack side, we have another tension which is the centrifugal tension. Okay, where if we consider the centrifugal tension, what happens, that centrifugal tension will be added to this formula. So initial tension is equal to, it becomes T0 plus T2 by 2 plus Tc. Okay, so that is the initial tension formula with the help of tension in the tight side and slack side and the centrifugal tension already acting during the power transmission. So this formula will give you the what is the initial tension is taking place when the pulley is under stationary condition with a tight friction grip over the pulleys. Okay, with a proper grip only we mount it, so during that grip it can have certain tension, which is the initial tension under stationary condition. So I hope you understand this simple explanation to derive an equation for the initial tension in the belt. So finally these two formulas are very important. Okay, with without considering the centrifugal tension and with considering the centrifugal tension. Okay, I hope you understand, and if you still have any doubts, please feel free to give a comment to my video so that I'll try to clarify your doubts. And please subscribe to my channel and share my videos with your friends over social networks. And if you really like, please thumbs up to my video, and keep visiting my channel. Once again, thanks for watching my video. Thank you all.